All right, so this first one, 20.1, just asks us why is it true. So for each of these, we just have to explain why they're true or why the two sides equal each other. So for one here, we have 5 plus 2 plus 3 equals 5 plus, and then we have 2 plus 3 in parentheses. So Chesney, why is that true?
Because when you're adding, it doesn't matter what order you add them in.
When we add, the order doesn't matter. And what do we call that when we talk about order? What property is that?
Order property.
Say it again.
Order.
Not commutative.
The associative property.
That's our associative property, right?
Definitely didn't look at the thing that has the 3 properties listed.
Well, at least we got there somehow.
Page 151.
So that's our associative property of addition that we can add in any order. All right, so 2, we have 9a is equivalent to 11a minus 2a. Why are those equal, or why are those true, Sophie? 11 minus 2 is 9. Now we've been working with factoring and distributing a little bit, so let's talk about it that way. This definitely works, and that's definitely right. But because we're working on factoring, if we just have 11a minus 2a, what can we factor out here? The a. So now we take an a out and we have 11 minus 2. And like Sophie said, 11 minus 2 is 9. So then a times 9 would be 9a. All right, 3, we have 7a plus 4 minus 2a is equivalent to 7a plus negative 2a plus 4. Why are those equal to each other? Kinley, why are those equal to each other?
Because subtracting 2 would be the same as negative 2.
Yep, we can say subtraction is the same as adding the opposite. Subtraction is the same as adding the opposite. Remember, we always talk about how if we don't know or we're not comfortable subtracting, we can put a plus sign right before that negative sign. All right, and we did move the order around, but that's okay because 7a and 2a are like terms, right? Over here we have 4 minus 2a. We can't simplify that any further. We can't do anything with that. So we just group up our like terms on the right side here because we can simplify 7a minus 2a, right? All right, the last one is a little bit tricky. We have 8a minus, and then in parentheses, 8a minus 8 is equivalent to 8. Autumn, why are those the same?
I said it because like the answer is 8, so like that equation would give you the 8, and then like 8 is 8.
So you're saying if we simplify the left side, it'll be 8?
Yeah.
I'd agree with that. Sophie, do you have something different? Same thing? All right, but let's talk about why this equals 8, because it might not be so obvious at first. What are we going to distribute out here? We're not going to distribute the 8. We're going to distribute this negative sign to our parentheses. This 8a is just going to come down and stay the same. But if we distribute the negative sign, now we have minus 8a, and then we'd have minus a negative 8. So now if we simplify this here, what's 8a minus 8a? Just 0, right? Those cancel out. And when we subtract a negative, that turns positive. So this side would equal 8, like Autumn and Sophie said. But to get there, we have to distribute that negative sign. All right? I know it might be easy just to distribute the whole thing because that's what's out front. But we just distribute that first term or sign right next to the parentheses there. All right, we're going to see that again today, so we'll talk about it a little more. All right. In 22, we have A's and B's. It says Diego and Jada are both trying to write an expression with fewer terms that is equivalent to 7a plus 5b minus 3a plus 4b. Jada thinks 10a plus 1b is equivalent to the original expression, and Diego thinks 4a plus 9b is equivalent. Do you agree with either one of those right off the bat? You think neither of them are right? We're not sure?
They both look bad.
Both look bad? All right. Well, let's go through one here and find out. This says we can show expressions are equivalent by writing out all the variables, explain why the expression on each row after the first one is equivalent to the expression on the row before it. So they've already kind of manipulated the expression for us. Now we just have to tell what they did to manipulate it. So in this first row, it gives us our equation again, our expression. And now what did they do to get from here to here? What did we do? Autumn?
Since there's like 7 A's, they took like A plus A plus A like 7 times.
Yep. So we just went from a product to a sum, right? 7 times A is the same thing as A plus A plus A plus A plus A plus A plus A. Only 7 of them, right? So we just went from products to sums in that first row, right? Same thing, 5 times B is the same thing as B plus B plus B plus B plus B. So products to sums from the first row to the second. Now what did we do from the second row to the third row? What changed? Kellen, what changed?
They took the 7 A's and split them into 4 A's and then 3 A's.
All right, that's exactly right. So now we have 7A into 4A plus 3A. Why do you think we did that? Why would we do that? Autumn?
Because on the other side of the equation, or no, like on the other side of the minus sign, there's like 3 and a 4. So you just do it.
Now we have 2 groups of 3A, right? All right. Those are eventually going to cancel out, right? 3A minus 3A is 0. So we're just grouping our like terms here. So that's what we did from our third row to our fourth, is we grouped 3A and 3A. So we put, here we had 4A plus 3A, and now we took this plus 3A and put it next to our minus 3A over here. We grouped those up. Because now these will just cancel out. 3A minus 3A is 0. So now we're already simplifying. So that was just grouping our like terms right there. All right, so then from our fourth to a fifth, we just simplified. Put 3A minus 3A equals 0. All right, now when we did that, we notice our B's lined up right next to each other too. Now we have 5B plus 4B. So how do we simplify 5B plus 4B? Jonas?
It's like 9 A's.
You just add them, right? They have the same variable, so we can add those. Those are like terms. So 5B plus 4B is just 9B. And that's all we have to say on this one. 5B plus 4B equals 9B, or we simplify it again. So then what are we left with? We have 4 A's and 9 B's. So that's kind of how we can simplify there by combining our like terms. All right, then from this one to this one.
On our practice problems, you want us to write out that many A's?
You don't have to write them all out, but maybe if you're struggling, it could help. All right, if you can do this in your head, that's okay.
That would make it more confusing.
All right? So then don't do it. You don't have to. It's just showing you another way to do it. All right, so we can kind of visualize how to combine our like terms. But then from this last row, we just went from sums back to products. We were adding all our A's here, now we're taking 4 times A. So from our fifth to our sixth row, we went from products, or sums, back to products. All right, now number 2, we left them all in our expression terms instead of expanding them out. But we're going to do the same thing. We just have to tell how we went from one row to the other. So the first row is 7A plus 5B minus 3A plus 4B. It's our same expression. What did we do from the first row to the second row, Chesney?
We put this subtraction sign and make it negative 3B.
Instead of subtracting in the first row, we went to adding the opposite. So now we're adding the opposite. Oh, yeah. Now we're adding the opposite. All right, what did we do from the second row to the third row now? Evan, what do we do from the second row to the third row?
We moved the 3A inside.
We put our like terms together, right? We grouped up our A's and we grouped up our B's. Because we talked about earlier today how adding, we can do it in any order, right? That's the associative property. So we can move these around now that we're adding. We can move them around however we want. So we just grouped our like terms. So now we have all our A's together and we have all our B's together. All right, now what did we do from the third row to the fourth row, Veronica?
The 7A plus the negative 3A, you put the 7 and the negative 3 in parentheses, and then put it outside of them.
So what do we call that when we take that A out? What have we been working on the last 2 days? That's factoring, right? We factored out an A?
Yeah.
Or our variable, because we took our B out over here too, right? So in both cases, we factored out the variable. Now we're just left with 7 plus negative 3 and 5 plus 4 inside there, inside our parentheses. So then from our fifth row to our sixth row, what did we do here? Chesney? We simplify. And then we distributed, right? We put that variable back with our term. So we simplified and distributed, or expanded. And you'll notice we get the same thing. So are we more comfortable with that second way?
Yeah.
That makes more sense? All right, that's totally okay with me. We can use this way too. This was just trying to give you another way to visualize. But if you don't like that way, you don't have to use it.
Yeah.
All right?
It would take me longer to write that thing.
Imagine typing.
We're skipping the are you ready?
A plus.
All right. So 23, we're going to make sides equal here. So we're going to do, there is 5 of these, and then there's a part B with 5 more. So let's go through these first 5 together, and then we'll let you do part B in groups. But we'll talk about that when we get there, okay? So for this first one, it says replace each question mark with an expression that will make the left side of the equation equivalent to the right side. So 6x plus what equals 10x? Not just 4. 4x. We have to have that x in there. Would equal 10x, right? Because if we have 6x plus 4, we can't do anything with this. These aren't like terms. We can't combine them. So that's as far as that one can be simplified. But if we have 4x, we can combine those to be 10x. All right? 6x plus what equals negative 2 or 2x now? Brooklyn? Negative 4. 6x plus negative 4x equals 2x. All right. So now 6x plus what equals negative 10x? What do we have to add to 6x, Brody?
Negative 16x.
Negative 16x equals negative 10x. 4 here. Brenna, what would we have to add to 6x to get to 0? Negative 6x. All right, and there is one more from those on the next page. We have 6x plus what equals 10. This one's a little bit trickier. So notice this isn't a 10x, this is just a 10. So do we have an x term over here? No. So what do we have to add to 6x to get rid of 6x? What do we do in 4 here? 6x plus negative 6x is 0, right?
Negative x plus 6.
So we'd have to add a negative 6 there to get rid of that 6x. But then what else would we have to add? We'd have to add 10, right? Because this isn't an x term. It's just a number term. So we can't combine number terms and variable terms. So we're going to have 6x plus negative 6x plus 10. And now we talked about this a little bit earlier. We're going to do our parentheses here with our plus sign. So to solve this, what would we distribute? We distribute that plus sign. So now we'd have 6x plus negative 6x plus 10. And if we solve that, 6x plus negative 6x cancel out, so those will be 0. And we're left with plus 10 Now we have 10 equals 10. All right, so for B, you can pick a partner, but I want you to go through these on your own first. So go through all 5 of these on your own, and then once both of you are done solving, I want you to check with each other. All right, and if you have questions on one or you didn't get the same answer, talk about it and see if you can figure out what one of you or both of you maybe did wrong to get it right, okay? So we'll give you about 5 or so minutes there to get through all those, and then we can talk about the homework after we discuss those 5.
Oh,
Maybe we should go find somebody else to ask.
Alright, I'll give you another minute or so.
I thought,
So we can go over them in the class.
4 by 10, and then get something like that, and then take 6 times that, and I get 60, excuse me. Did I do that? All of us have different answers.
Are you listening to us?
Can't combine.
So 6x minus 6 is. Which is the number that with no.
Yeah, minus 6x.
All right. You guys want to get back to your spots? We can go over them as a class. Okay, I think these first three were pretty easy. We all looked like we did okay on those one. So 6x minus what equals 2x? 4x. All right, 6x minus 4x equals 2x. How about 6x minus what equals 10x? Negative 4x, because then we'd be subtracting a negative, and we'd be adding, so 6x plus 4x equals 10x. 6x minus what equals x? 5x, right? So 6x minus 5x. Remember, anytime we just have a one variable, there's a 1 in front of it, right? 1x is the same as just x. Right? So then 6 minus 5 would be 1. And you can always write it as 1x if you want, but just know that it's the same thing as x. All right, you have a question, Kellen? All right, you want to try number 4?
Is it parentheses around 6x minus 6x, then plus 6?
Where are your parentheses? So I like 6x.
Around 6x minus 6x.
So you're saying right here? And then what sign would go here? It would be a negative here, right? So 6x minus, and then in parentheses we have 6x minus 6. Because now we'd have to distribute this negative. So 6x negative times 6x would be negative 6x. And now we're subtracting a negative 6. So 6x minus 6x. Cancel out. And now we're just left with plus 6. All right? So going to be the same kind of thing on 5 here. 6x minus, what's going to go in these parentheses to get us to 4x minus 10? So 6x minus what gets us to 2, or gets us to 4x?
Minus 2x.
Minus 2x, so that's what we'll start with. And now we need a negative 10 on the right side. But remember, we're going to distribute this negative. So what goes in the parentheses here?
Plus negative 10.
Just plus 10. Right? Because now we'll distribute this negative. And we're left with 6x minus 2x minus 10. So then 6x minus 2x is 4x. And we're left with 4x minus 10. All right, is that starting to make a little more sense? I know it's a little confusing. Not really? All right. All right, so anytime we have subtraction like this, we can only combine our like terms. So we could just write 6x minus 2x plus 10. But then that 10 is going to be positive, right? So we're not quite going to get there. So we have to have this negative out front to distribute to make the whole thing work. Or in this case, it was a positive to make the whole thing work.
Over a couple more examples already, a couple on.
Yeah, sure. Alright. So now, how are we going to set this one up? We see that we have 4x minus a variable term and a number term. So we're going to start it the same way we've been starting these last two, right? We'll start with 4x minus, and then we know we're going to have parentheses here because we have two different terms. So 4x minus what gets us to 3x? 1x, or just x, right? Now we need a negative 8. So what's going to go here if we're going to be distributing this negative? It'll just be plus 8. Right, now we distribute the negative sign here. We get 4x minus x minus positive 8. 4x minus 8
3x.
is just 3x. And we're subtracting 8, so we're subtracting 8.
Should have a minus 8 in the parentheses there to start.
This should be minus 8.
Do negatives make that.
Because then the negative would make it a plus. And that would be a plus as well.
There's one more on the left side there for you to try quick. Notice there's no X's on the right, so what does that tell you about the 4 X's? How do you get rid of them? How do you get rid of 4 X's?
Negative 4x.
Subtract 4x. And then we just do plus 13. So we distribute that plus. We get 4x plus negative 4x plus 13. So these would cancel out. And we're just left with 13. Is that starting to make a little more sense?
Sure.
The negatives add one extra step. Negatives are just a little tougher.
All right, so let's set up the homework quick. We just have a couple minutes left. 20. One says Andre has 10x plus 6 and 5x plus 1 are equivalent because they both equal 16 when x is 1. Tell me if you agree with that, yes or no, and then explain why. So yes or no, that makes sense, and tell me why. 2 says select all the expressions that can be subtracted from 9x to result in the expression. So it does say all. So we're probably going to have more than one. In this one, we are going to set up how we kind of been working. So put 9x minus, and then if these answers would go in this parentheses to make it work, those would be the answers you select. So take all these expressions here and plug them into this set of parentheses and tell me if that would result in 3x plus 5. We okay with that? All right. 3 says select all the statements again that are true for any value of x. So we could just plug and chug here, but what's a better way to figure out all the true statements? Not 0. What's the whole lesson on? What's the lesson called? Combining like terms. So if we just combine our like terms, right? Here we can distribute the positive again, and then we can simplify. What's 7x plus 2x? 9x. We can't do anything with that 7, so is 9x plus 7 equal to 9x plus 7? Yep, so that would be one of them. So go through there and combine your like terms and simplify those and see if you get the same thing on both sides of the equal sign. All right, 4. It says for each situation, would you describe it with one of the following? So it gives you your inequalities, and it just asks for A, B, C, and D, which inequality would describe the story or number line there. So just write down which inequality best describes each one of those. And 5 says, consider the problem. A water bucket is being filled with water from a water faucet at a constant rate. When will the bucket be full? It just wants you to tell me what information would you need to be able to solve the problem. So what are some things we need to know so that we could tell when that bucket would be full? So just write down a list of things you would need to know to say when that bucket would be full. Any questions on the homework? Good to go? All right.